Thanks for joining us today. I'm Chris Bacon. I'm the owner of rvengetransmissions.com. We believe in really helping our users out, our customers, with any kind of instructions we can give them on installing the transmission and performance parts that we sell. We rebuild these transmissions here. This is for a Dodge Stealth or 3000 GT VR4 or a Dodge Stealth Turbo. They're all-wheel drive vehicles. They have a very heavy-duty transmission. I know there's a lot of information out there that seems to suggest that their transmissions are actually weak, and they're really quite durable if you take good care of them and you really kind of take care of a few of the weak links they do have. We do sell parts to beef them up, like 300 M output shafts. We sell bell housing braces. We sell high performance carbon synchronizers. We sell a bunch of OEM parts as well, such as seals, gears, hubs and sliders. We sell high quality aftermarket bearings. We sell just a wide variety of performance parts, upgrades, and maintenance items for these transmissions. And we are also beginning to sell some driveline components such as clutches and transfer case parts, things of that nature. Like we said earlier, we believe in helping our customers. We realize that a lot of people want to tackle their own rebuilds, and that's totally fine with us. And one of the things you might run into when you're rebuilding one of these transmissions is needing to set the bearing preload or Endplay on any of the bearings in the transmission. The majority of the bearings in the transmission are actually tapered roller bearings, and so they will have some preload, generally in the neighborhood of 0.1 to 0.25 or 0.3 millimeters of preload. The Getrag factory manual actually lists all those preloads out if you want to know exactly what they are, but generally if you're between 0.1 millimeter and 0.25 millimeters on any of the tapered roller bearings in these transmissions, you're going to be good. One exception to these tapered roller bearings in these transmissions is actually this little bearing here. This is the input shaft bearing. Now this is the one for the end case, so this should not be confused with the bearing for the front of the transmission that contains the snout that also the throttle bearing runs on, and so that is a different bearing entirely. We're talking about the end case input shaft bearing today. So we sell a very high quality version of this bearing on our website at rvengetransmissions.com. This is an FAG brand, and it's made in Germany. This is one of the bearing manufacturers that the OEMs at Getrag use for a lot of their transmissions. You'll find when you take a lot of these apart, they'll often have FAG bearings. You might see some Timkins. You may see some Koyo. That's kind of the majority of the ones you're going to see. So this is an OEM quality unit. It's quite a bit more affordable though than buying the part number from Mitsubishi. We currently sell this for $79.99, and we also include brand new bolts with your order as well. As we'll show you in a little bit here, this bearing is retained by a steel retainer plate, and it uses these 6 millimeter Allen bolts here that are 20 millimeters long. These are countersunk Allen bolts, and so they have a very strong tendency to seize up over time. The majority of these transmissions may have not been serviced for 20 years, and so there's going to be a kind of locking effect built into that. The factory also used a little bit of Loctite on these, and so you may find a little bit of heat might help you get these loose. Another thing we often do is when this gets rounded out a little bit, we will use a Torx 27, a T27 bit to get into here. That will grip these corners a little bit better than the 4 millimeter Allen socket that's supposed to fit this. You may also find that you want to use a hand impact driver, which is one of those tools that has the bit on the end, and you smack the head of it with a hammer and it will try to rotate the bolt. That shocking action will often break this loose as well. You may find at the end of it you can't get these out, and that's okay. They're fairly easy to drill, especially if you have a left-handed drill bit. I'd highly recommend picking those up if you can. If you basically drill out the bulk of this countersink here before you really get into this plate and start to damage it, you'll see this screw right out. And if it doesn't, you can kind of pop the heads of these off And once you get the retaining plate out, you're going to go ahead and be able to thread these out just with a pair of vice grips or pliers or anything. They're not very tight once you get this head off of them. So this has a critical dimension in this case. You're going to see when you get your end case off of your transmission, you're going to see a situation similar to this. You know, there'll be bearing races in here for the center differential and the countershaft, which we have currently removed from this transmission. But you'll also see your reverse idler assembly here, and there's this bracket piece here that has a bolt on this end and one going through the top, and there's a little horseshoe shaped washer here that holds this all assembly together. So once you get those two bolts out, this will just slide right out. Has a needle bearing in it you want to inspect to make sure there's no damage or debris or scarring or anything like that in there. Then you're going to want to take your reverse idler out, and again, you want to check in here. You can see this one's fine. You will see sometimes there'll be some needle bearing kind of brinelling in here. If you do see that, then you may want to get a new part of this. We can help you do that at rvengetransmissions.com, or if any braking yard or anybody like that you can talk to, you could probably get one fairly affordably too. These needle bearings are available. But they usually are okay, so you usually don't run into a lot of problems with these needle bearings. If these spin smoothly, there's just really no use in replacing them. You have a pretty hard time getting this one out. What we find gets these out when you need to is a pilot bearing extractor or puller. You can use that, which is a part that expands here, and you set that on a slide hammer and you can pull that out, so that's okay there. We've already got this part removed, this bearing retainer. You can see here that this is what this is going to look like once that's removed. Previously, we knocked this bearing out, the original bearing from here, and it's not much of a press fit in the case, and so all you'll need to do is tap it with a socket. It sits in here like this actually, so you'll tap that with a socket and that'll fall right out, no problem. So some of the reasons you might want to replace this bearing is you're going to want to spin this carefully and listen for any kind of noise. If you hear any screeching, scratching, any kind of sign of dirt or contamination or ball bearing wear in there, you're going to want to replace this. You're also going to want to look for excessive thrust play. So this is a ball bearing, we've mentioned it earlier, but this does not have preload to it like a tapered roller bearing would have. So there is a little bit of thrust play here. You probably can't see that, but I can move that just a little bit. And that's okay, but if you find that yours can really rattle back and forth like that, maybe about twice as much as what a new one will do, then you really should replace it. We believe that this contributes to the rattle that some of these Getrag transmissions have, is when this bearing gets excessively worn, then the input shaft is allowed to move axially through the transmission, and this only contributes to some of the rattle that you're going to hear. The other thing we believe is if this bearing is tighter, obviously that's going to put a little bit of drag on your input shaft, which is actually going to improve upshifts. When you go to upshift a transmission, a typical transmission, your synchronizers will attempt to slow down the input shaft on the next gear so that everything is synchronized and the shift is smooth. So if you have a little bit of drag from good bearings in the transmission, then that is going to help the synchronizers have an easier life, and it's just going to be a little easier for them. So one of the critical things about any kind of bearing in a transmission, and especially in this particular measurement we're going to do today, is getting the Endplay or the preload correct. This bearing actually has Endplay, and so that's a little unusual because a tapered roller bearing always has preload. But remember, this is a ball bearing. So if a ball bearing is preloaded, then it will actually burn up pretty rapidly. They're not made to tolerate much thrust load. And so the specification on this is 0.02 to 0.05 millimeters of Endplay, and that's a very small amount. That's just a very tiny measurement. You want to get that right, because if there is preload or no Endplay, you can actually damage this case, because once this bearing retainer is in here, if this bearing heats up and expands, it's going to try to pull away, and it could actually crack the case, or it's going to damage this bearing by getting too hot inside from being overloaded in the thrust direction. The other problem you could have is if you have excessive Endplay, this could actually, the whole bearing shell could rotate in the case and slip. That will happen if these bearings go bad and they tend to lock up. And they're really their end stages of failure. This bearing will start to have a lot of drag and lock up, and it will spin in the case. You can actually ruin your end case doing that, as well as the bearing retainer, and it will also allow the input shaft to counter shaft gear mesh to really get out of whack, and you could end up excessively loading all your gears and wearing the teeth out as well. So there's a lot that could go wrong in that. But by having the correct amount of end play, this is the least likely to slip in the case, and it's going to stay where it's supposed to and live a very long life. So the way this is set, this end play is set just like all the other preloads in the transmission. This is set using these steel shims. The factory uses multiple steel shims at every location in one of these transmissions. You'll typically see between 1 and 5, in fact. The ones you'll see the most on is really the counter shaft, the center differential assembly tends to have a very large, a very thick stack of shims on it for whatever reason. I'm not sure if when they were casting and machining the mid cases they had a lot of variance or what was the reason for that, but you'll often see up to 1.4 millimeters of shim stack on the center differential assembly, which is a lot compared to these other ones. You can see here. So to measure this end play or the preload on any of these bearings, you're going to need a pretty accurate measuring device. What we have here is a high quality Japanese digital micrometer, and this is, you know, a little bit overkill for what we're doing today. Since our specification is between 0.02 and 0.05 millimeters, we really don't have to get down to the 100,000ths or anything like that. But we prefer using this because it's very easy to zero when we start, and also it just grips these shims very well when we stick them in, and we get very repeatable results from this. You can use a device. You know, what we have here is basically typical of your imported digital calipers. They're very affordable. It's going to give you fairly good results, so don't think that you need a tool of this quality to be able to do this job. Before we set the end play, I want to talk about the shims in these transmissions. So these are all set with a steel shim, and so there's multiple shims in these. We talked about this just a little bit earlier, but the first thing I always do is I check the original shim stack to check the height on it. So if you check this, for the purposes of this, we're just going to measure both of these shims together. It is a little more accurate to measure them independently and add them up because you just don't know how hard you're squeezing on these two together, and so you're going to vary just a little bit sometimes. But this will probably be good enough for our purposes. We'll see here in a minute. So this is 0.696 millimeters of original shim, and we can fairly reasonably call that about 0.7 millimeters of shim. We are going to use the solder method to determine if this is the correct amount of shim. Very often when you replace just a single bearing in one of these transmissions, or even a bearing on each end of one shaft, you're going to find the original shims are okay. If you change one of the castings, such as an end case, a mid case, a bell housing, or change one of the shafts, you're going to see a lot more variance. And certainly we have almost never seen the shims be correct if we're changing a part of the casting. That's really why they developed these shims. It wasn't for tolerances and bearings. Bearings are so precise, they're manufacturing those to tens and hundreds of thousandths of an inch. And you're going to get a lot of repeatability in that. But these transmission cases were all just cast aluminum, and so there's going to be a lot more variance in that. And that's really why these shims are fairly consistent, just changing out bearings. And that's another good reason that you got to be very careful with these shims, especially if you're not confident setting your preloads. Make sure you keep them with your transmission, and make sure that you don't throw them away, and you always got the original reference value. If you find that your shims are having to change a lot and you really haven't changed much in the transmission, then I would be suspect of your measurements, and you should probably check it again. We'll get into some other videos on doing the preload on some of the other shafts at a future date. But like we said earlier, today we're going to focus on this input shaft end case bearing, and this is one of the easier ones to set. By the time you get this all apart, you can see here you have full access to this bearing. You're not having to put the case back together all the time. Just this little part here. It's really extremely easy, and we're going to do it right now. So what we've done to get started this earlier, you can see here we actually have, they look a little greasy, but there's 2 pieces of solder in there. Each of those is approximately 10 millimeters long, or 1/3 of an inch. And the reason they're greasy is because we just put a little axle grease on them before we put them in there, and that really keeps them from falling out. And it's just really frustrating if you have those fall out when you're assembling the whole case, like if you're doing the counter shaft, preloads. You really don't want those to fall out. And so that's the only reason those have grease on them at all. And it won't affect our measurements whatsoever. I want to talk just a little bit about the solder we're using here. So this is kind of the thicker solder you're typically going to find. If we take a measurement here, you can see here this is about 1.7 millimeters. So that's pretty thick solder. Pardon me, it's just a little round. We'll get it in there though. Yeah, so about 1.8 millimeters almost. And the other thing we check with our solder when we're getting it is we like to use the highest lead content you can find. So if it's a 60% lead, 40% tin, that's going to smash a little easier. It's just going to be more malleable, softer, and it's going to work better for our purposes. The other thing we do is I usually cut it past these curly Q type of things because you really just don't want that getting lumped up in your measurements. You just want it the straightest piece possible, so straighten it out when you do it. Okay, so once again we have these 2 pieces of solder there. We are going to go ahead and set this bearing in here. This bearing is directional. You can see here that the retainer sits on here, and that is gripped around that collar, the ridge on the bearing, and this part is what goes on the outside. So one other thing to note is this is a press fit on the input shaft, and that is why when you take your end case off, get your input shaft out of it, it doesn't just fall out. It's a press fit. We use either a very large gear puller to pull this end case off the input shaft, or we have also used the press to do that. You can put the whole gear assembly in the press. That's just a little more awkward to do. And the thing we would avoid is try not to pound on the input shaft to knock it out. People do that, and they have done that for years, and on the forums they've had threads where you can replace the output shaft in your transmission by pulling the end case off while the transmission's in the car, and they beat the input shaft through. And you can do that. We just, try not to beat on anything in these transmissions if you can avoid it. They're, not delicate, but they are precision instruments, and you don't want to damage them. If you do beat on your input shaft to get it out, be extremely careful that you're using a socket or something up against your input shaft and you're not dinging up the input shaft. But the other thing I would recommend is if you're going to beat your input shaft out, go ahead and replace this bearing. This bearing is not designed to be hammered on. There are steel balls in there that are just getting beat to death when you beat on them with a hammer, and every time you hit that thing, that's going to be a little bit looser. You have a little more thrust play. So if you must beat your input shaft out, just go ahead and order a new bearing. RVengeTransmissions.com, we have a kit. We have this bearing, 5 bolts. You only need 4 of them if you have a 5-speed, so you'll just have an extra. And that way you don't have to worry if you mangle them up. You're all set. So let's get on to actually doing this. We've had an introduction. What we want to do is go ahead and place this bearing into here and work it in. And you're going to see that here it's going to want to kind of hang up just a little bit. You got to be careful how you're putting that in there. So what we have here is just an aluminum seal driver, a bearing driver kit piece, and we're going to use that to cushion this bearing as we knock it into the case. You shouldn't really have to hit on these that hard. If you find that you are hitting on it pretty hard, then you may want to check to make sure that it's evenly set up in the case. You're probably driving at an angle, which can tear the case up, so watch out. So we'll just place that on top and tap that the rest of the way in. You can see there that knocked down pretty far on that last hit. One thing you want to be careful is that you don't knock it in so far that the solder actually gets smushed, and that's going to ruin your measurement. Okay, so we have this bearing most of the way installed into this case. You want to be sure that you're not driving it so far that that actually compresses the solder, and that's really going to wreck your measurement and make it look like your numbers are way off. So we have this ready to go for this retainer here. This retainer plate only goes in one way, and the reason you know that is because there's a little gap here for part of the reverse idler. As we mentioned before, these are M6x20 countersunk Allen screws. We include them with the kit for this bearing, but you are able to get these a lot of places if you look. You want to be sure to get a very high grade bolt. These are 10.9. I'd recommend that. That's just going to make it easier to get these out in the future if you ever need to. And also make sure that you have adequate clamping load for these tiny little bolts, which are going to actually take 7 foot-pounds or 84 inch-pounds of torque per the specification. So we're just putting these in here dry. On your final assembly, you're going to want to use Loctite, and what we would recommend is Loctite 243. This is a medium strength surface insensitive Loctite, and what that means is if there happens to be just a little bit of oil left on some of your threads or anything, it's not going to make the Loctite completely ineffective. So I'm going to go ahead and just use my 4mm here to install these. I would not recommend beating on these too hardly with an impact tool to tighten them if you want, just because you don't want to really beat out the socket part on here. And you want to work in a crisscross pattern just in case that bearing isn't all the way flush. You don't want to start putting it in at an angle, and that is going to mess up your measurements. When we get to measuring the solder, I'll talk a little bit about some things to watch out for. But one of the big things is if the bearing race gets cocked in the case when it's installed, one of your solders may read a lot different than the other, and that normally means you should redo it. You can attempt to average the solders, but that could give you inconsistent results, and it's just a good idea to start over if you find too much variance from side to side on your solder. They're going to be a little bit off, but if you're seeing like 1/10 of a millimeter off, then you probably need to redo it. So I'm just snugging these up by hand, this ratchet here at this point. And you can see here that is drawing that bearing in a little further. And we're going in a crisscross pattern just like you would on a wheel. We're now going to change to using a torque wrench. This is just an ordinary Craftsman torque wrench. It's really nothing special. One thing to keep in mind is this is only 7 foot-pounds or 84 inch-pounds. You don't want to use a torque wrench that starts at 5 foot-pounds because you're going to be so close to its lower limit that you really can't depend on its accuracy a lot, and you could get some false clicks. This has, I forgot the exact range on this, but basically we are close to the middle of the range on this torque wrench at 84 inch-pounds, and so that's going to assure we're really in the the meat of the accuracy of this tool here. So we're going to go ahead and torque these to spec. And again in a crisscross pattern. Okay, once those are torqued to spec, just to show you how this is installed in the transmission, your input shaft would normally be through here and your bolt would be here, or your bolt and washer if you have the smaller 7mm socketed size. And that would be installed. We're going to go ahead and take that back out now because we need to measure our solder to determine if our current shims for the Endplay are correct. switching to the smaller tool here to be a little quicker. And if you have a small impact tool, this might be useful to get these out. Remove our retainer plate. We're going to want to turn this case over. And we're going to want to get that bearing out. You can see here that that fell right out. It's great if that happens. If that doesn't, get a socket that fits inside here and lightly tap on that, and should come right out. You will often find witness marks on the bearing here where the solder was, which is great. Sometimes the solder will stick to the bearing and stay with it, and that's also fine. Just be careful to pick it off, that you don't disturb the solder size very much. But we'll set this aside. You can see here the solder is quite flattened, which is a great sign. If you don't see that flattened, you may need to make some adjustments to your technique. Particularly for the center differential, since we said earlier those are 1.4 millimeter. If your solder's not that thick, you may find that it's just not going to get matched at all and you'll have no reading. What you can do is you can either get thicker solder or just reinstall one or two of the original shims and then do the solder, and that will mean you'll just need to add the results of the shim and the solder to get it. What the solder is really telling you is what it would be at 0 Endplay or preload, because the solder will mash to fill the space that the bearing has to the case, the bearing race. And so if you need to put a shim in there to have solder on top of that, then you would just have that cumulative measurement, and that's just fine. So we're going to go ahead and pick this solder out carefully, and once again, you don't want to be too brutal on it because it may get mashed and ruin your results. You want to look very carefully here to see if there's a ridge. On this particular piece, there's not. If there's a ridge, you're going to want to measure the thinnest part of the ridge, because that just means that part of the solder did not get smashed, which may be because it's inbound of the race or something like that. It's not always something to be concerned about. You just don't want to measure the thickest part and think that that's your measurement, or you're going to put shims in there just way too thick. So we're going to go ahead and measure this piece of solder. And we come up with 1 millimeter here. And we'll check it at a couple different spots. There's 0.9, so we may need to be a little more careful that we're not getting any kind of ridge. We want to get the thinnest section, 0.9. Okay, so far we have about 0.9 millimeter. I would write that down at this point. We'll just keep that in mind for now. And now we have our other piece, and that also has a ridge on it. So we're going to want to make sure we get the thin section. See here we have about 0.880. Check that a couple times. I apologize if it's hard to read these numbers, but that says 0.880. 0.9 and 0.880 are close enough that I would feel comfortable averaging those. If this was 0.80 and the other one was 0.9, then I would want to redo the process because I probably got the bearing cocked in there or something like that. So we have approximately 0.9 millimeters of solder being smashed, and that's telling us what 0 Endplay would be. And we currently have, check these once again, a couple spots. We have about 0.7 millimeters of shim here. So what that tells us is we have about 0.2 millimeters of Endplay. So this is one of the rare cases where the factory shims are not going to work really well. If you recall, we had 0.7 millimeters worth of factory shims. We came out with about 0.870 worth of solder, and that would give us 0.17 millimeters of end play. The factory specification is 0.02 to 0.05 millimeters of end play. So we've had to add approximately 0.1 millimeters of shim, which has gained us the correct amount of end play. So we're about 0.830, and we measured the solder once more, and it was about 0.870 to 0.880. So we're right at our 0.05 millimeters of end play. And this is just going to be perfect. And that is, now that we've determined the proper amount of shims here and got our end play to specification, the only thing left to do is just really put it back together. You can see here that these three are all of the shims that we sell here. We did not use any of the OEM ones in this case because to come up with the exact thickness amount that we wanted, this is what it took to do so. So these fit in just fine. You can see that that's a perfect fit for this bearing race. You really don't want to try to use just any random material you have for a shim because you want that good fit because it'll fully support the back side of the bearing. You also don't really want to use a shim made out of a piece of aluminum or something because this is hardened steel, and because there could be some load against these shims, and if it's too soft a material, it's going to deform over time and your end play is going to change. So you would just put these back in, and then all you would have to do is install your bearing in the correct direction, which this part faces outward. You would get that seated in there very nicely, and use an appropriate tool to tap it in. And now that bearing is fully seated, once you finish driving that, you would hear the tone change, and that would be all the way in. You would want to put your bearing retainer into place and Loctite up your bolts. Make sure that no debris gets in there. Got a little sliver of something. And that's why it's very important to have a very clean workspace here. You don't want to get debris into your transmission. These transmissions, in fact most manual transmissions, don't have a filter of any kind inside them, and so any kind of dirt, hopefully it falls to the bottom of the case with your fluid in the bottom, but it could get circulated throughout your transmission, and that could damage and score your bearings and your synchronizers and gear teeth. So we would just use a small amount of Loctite. You don't want to get too much, especially not up towards the countersink, because that's just going to make it very hard to remove in the future. These bolts don't really have a tendency to come loose. We just like using Loctite because since it's only 84 inch-pounds, we don't want any chance that they're going to come loose from vibrations or anything like that. You also have to be very careful. You can see here that it is taking me a moment to get these to start and begin turning in properly. And the reason for that is just the threads are just so small, you really got to work a little bit to get them lined up. And you don't want to cross thread one of those because they can be pretty difficult to repair effectively with any kind of helicoil just because they're so small. You really don't want to have to go through that. Once again, we're going to want to go in a cross pattern. It's not quite as critical that we take so many steps like we did before with that, because the bearing is fully seated and we don't have to worry about the solder getting deformed unevenly. But we just don't want to pull a bearing into the case at an angle and tear the case up at all. You can't. I have seen plenty of cases that have been rebuilt before that someone has clearly driven the bearing in very hard at an angle, and it's just puts a little ridge here basically, and that just makes it harder and harder to move over time, and can actually make the bearing race just not sit very well in there, and you're going to have some problems with that. You really should not have to really beat on a bearing race to get it into a transmission. If you do, you really want to check and make sure that you're not driving it in at an angle, and you may want to remove it and try again. It really doesn't hurt to very lightly lubricate the outside of a race, and that might make it go in a little better. And you see here we are doing a couple things. With any kind of Allen fastener, you have to make sure that's fully seated, and otherwise you're just going to strip that out. And we went in a cross pattern and we torqued them all to 84 inch-pounds. Once I've done the cross pattern once, I like to double check my work by just going clockwise. So we've got all 5 of those definitely. A final step we take, and I like to do, mark each one of these that you've torqued. And so you can use a white paint pen if you have one handy. That works really well. This is just a Sharpie. What this lets us do is, if this case sits around, let's say you end up working on parts, life gets in the way, you take a vacation, let's say this sits for a month, you come back later and you assemble it. You don't want to second guess that you torqued any of these bolts to spec. And so I like to do this on this piece. If you take the ring gear bolts out of the front differential, that's another good one to do. Just like to be very careful that this is done this way. So even if you have another one, someone else comes along, another one of your technical people or transmission builders and does this, they know right away that, hey, this has been done. I don't have to worry about torquing that. Because the last thing you want is one of these bolts to come loose because they're not tight. That is going to slam into the input shaft, and your whole transmission is probably going to get chewed up and ruined. Appreciate your time today. I know this video was a little lengthy. A similar process takes place for essentially all the bearing races in these transmissions. Is a few more details that we may get into in a future video for those, but as you can see, really this is not too hard of a job. This is something you can do. You can replace this.